Welcome back everyone to this day 15 of custom transformers and feature scaling. In this session, we are going to look at feature scaling and creating a custom transformer. We have looked at ordinal encoding and one not encoding, where we have converted categorical attributes such as uh, small, medium, and large scale to a numeric value in ordinal encoding, and similarly colors or different uh, values of colors to a one hot encoding type value with the numerical conversion. So consider feature scaling also something similar, but we will look at it, right? So custom transformer, let's take an example where we are given with height and weight. So it would be more meaningful if we convert it to BMI or body mass index. So know that BMI is of a more useful feature rather than looking at two individual features of height and weight of a specific person. So yeah, let's look at how we can build a custom transformer to create BMI from a specific data set which has height and weight in it, right? So a custom transformer will have always these two methods, a fit and a transform method. So in this case, we are not going to do any fit or any learning on the existing database, be having to calculate mean or min max of a specific value and then adjust or transform this value accordingly in this case of calculation of BMI. So a BMI is calculated with weight and it is divided with meter square. So in this specific data set, height is in centimeters, so we convert it to meters and then we calculate BMI with square of meters, height in meters. Okay, so we get this BMI value this way, right? See that a person of height 150 with weight has a lower BMI index, and similarly a person with higher height and a slightly at 10 kgs heavier person is having another BMI value and so on, right? So see the way that BMI values are given. Next is feature scaling. So feature scaling, there are three different techniques. We have standard scalar, min max scalar, and robust scalar. In case of standard scalar, so we have a specific value which we uh, the way that standard scalar is calculated is it's subtracted with mean and divided by standard deviation. So for example, uh, a mean value is calculated like a mean is sum of all the values divided by the total number of values, which would give the middle kind of a value. And deviation is nothing but uh, difference with the mean. Like for example, let's say in this case of this data frame, so a mean value can be considered as 170 and a deviation of 20 here, minus 10 and plus 10 plus 20. So that might be a deviation. So the way that standard scalar is calculated uh, for height here would be uh, a minus 1.44 or a 20% variation with this 0 and something going away with minus 20% and another extra 20%, and the same goes here, a minus plus on the plus scale of zero point 0.7 and 1.4. So that's the way that standard scalar is calculated. It's a simple formula where a value is subtracted with mean and divided by a deviation value. Similarly, in min max scalar, there is another formula where the value is divided or subtracted by a minimum value and divided by the difference between the maximum and the minimum value in the specific feature. So as you can see, it ranges from 0 and goes all the way up till 1. And robust scalar, in case of robust scalar, there is another way to calculate it. It is calculated with uses the median and interquartile ranges, so extreme values have less effect. This helps in avoiding many outliers. Mm, i- all of these might be very useful. Please do post your thoughts or guesses on which is more useful out of these three, either the standard scalar, min scalar, or robust scalar, which is more used in machine learning algorithms, right? So one helpful thing that feature scaling does is it brings down these values to a more uh, easier ranges or a predictable range, so that machine learning models have easier way to use them, right? So that's one thing. Do post your comments, and please do uh, take a guess at which is more useful, and also support your answers with what is your reason, right? Okay, so let's combine both of these, transformer and feature scaling, either a standard scalar or any of these, one of these. So I have a pipeline here which transforms to a BMI feature and also scales the value as such with standard scalar method. So here is the output for the same. So yeah, we can use this BMI value in a lot more predictable way. You can see that um, here you see double the variation, and here you see the positive side of the variation. So that's about custom transformers and feature scaling, right? So this would be more helpful in machine learning to have a standard set of pipelines and create custom pipelines, so that machine learning models will have better better features or more meaningful features to work with, right? So these are few practice points that you could try out also, right? So we are going good with our learning. Hope you're enjoying this playlist. Please do like and subscribe to my channel. See you in day 16. Thank you.